Hey guys, Drifter ZZ here. Today we're going to replace the controller on a ProForm Tour de France bike. To start, we're going to remove the top cover and sweat shield. Next, remove the right-hand crank arm. Be careful not to loose the spacers between the crank arm and the crank. On this model, the crank arm attaches using a simple bolt-on design, which makes removal very straightforward. Once the retaining bolt is loosened, the crank arm slides off the pedal spindle without needing a puller or any specialty tools. With the crank arm off, you can see the pedal spindle and the sealed bearings that support it. This model uses a cartridge-style bearing setup, pressed into the housing, and designed to stay lubricated internally. The sealed design helps protect the bearings from sweat, dust, and moisture, which are all common around indoor fitness equipment. These bearings are responsible for keeping the pedal motion smooth and stable, and they carry the load from both the rider and the resistance system. The pedal spindle runs through the bearings and connects to the drive components on the opposite side, so any roughness or contamination in the bearings can be felt immediately during pedaling. Removing the crank arm is also a normal step when servicing the drive system, checking belt alignment, or accessing wiring. Next, remove the right shield. There is one screw on the other side as well, connecting both shields together. After the right shield is off, you will find two hidden screws inside holding the left side shield. The left and right shields on this model are made from molded ABS plastic, which is lightweight but strong enough to protect the drive components. ABS is commonly used in fitness equipment because it resists cracking, handles vibration well, and keeps dust and sweat away from the internal parts. This is the before-mentioned screw connecting both shields together. As these shields come off, you can see how they're shaped to follow the frame and cover the entire drive section. Each panel is contoured to sit tight against the bike so it doesn't rattle during use. The mounting points are positioned around the edges, which helps spread out vibration and keeps the panel stable when the rider is pushing hard. Taking the shields off opens up the whole side of the bike, giving access to the belt path, the pulley, and the wiring channels that run along the frame. Here are the two hidden screws holding the left shield on. Remove the two screws holding the controller bracket in place. The controller attaches using plastic clip-on risers that snap into the mounting bracket. These risers hold the board at the right height and keep it locked in place without needing screws or metal standoffs. Carefully remove all of the connectors from the controller. As each connector is unplugged, you can see how the wiring is organized around the controller. Every plug has a dedicated position, and the harness is routed so the wires stay separated and don't rub against the moving parts inside the bike. Most of these connectors are keyed, meaning they only fit in one direction, which helps prevent mistakes during reassembly. The different lines coming into the controller handle things like resistance changes, incline control, power input, and the signals from the sensors up in the console. Disconnecting them one at a time keeps the harness from getting tangled and makes it easier to trace each cable when installing the new board. Once everything is unplugged, the controller is completely isolated from the rest of the system and ready to be removed. Pinch the end of the mounting clips to fit them through the holes on the controller. The controller is the central brain of the bike, managing all of the communication between the moving parts and the console. It takes the signals from the resistance system and translates them into the levels you see on the screen, making sure the magnetic resistance responds smoothly as you pedal. It also handles the incline and decline commands, sending power to the lift motor and monitoring its position so the grade changes match what's displayed. Every sensor on the bike feeds into this board, including cadence, speed, and the inputs from the console buttons. The controller constantly checks these signals and adjusts the output to keep everything running in sync. It also manages power distribution, making sure the motors and electronics get the correct voltage. Without this board, the bike wouldn't be able to coordinate resistance, incline, or any of the interactive features that rely on real-time feedback. Make sure you don't have any wires in the path of moving parts. Install the shields. As the left shield goes back on, you can see how it lines up with the frame and the mounting tabs around the drive area. The shield has a shaped contour that fits tightly against the bike, so getting the edges seated correctly helps prevent any vibration or rattling once everything is running again. Reinstalling this panel also closes off the wiring and belt path, keeping the internal components protected. Line up the spacers before installing the crank. One thing that isn't immediately obvious about this bike is how much of the internal layout is designed around service access. The entire drive section is built so the belt, pulley, and controller can be reached without taking the bike apart any more than necessary. Even though it looks fully enclosed from the outside, the internal frame has open channels that let wiring pass through without getting pinched or rubbing against moving parts. Another lesser-known detail is how the pedal spindle and bearing assembly are positioned. The bearings sit in a reinforced housing that's part of the main frame, not the outer shields. That means the pedaling load is carried directly by the steel structure, which helps keep the motion smooth and reduces long-term wear. The spindle itself is supported on both sides, which keeps it stable even when the rider is putting a lot of force into the pedals. The resistance system also has an interesting design choice. Instead of using a physical contact brake, it relies on a magnetic setup that adjusts electronically. This allows the bike to change resistance quickly and quietly, and it also means there's no friction pad to wear out over time. The magnets are positioned around the flywheel so they can increase or decrease resistance without ever touching it. The wiring harness is another part people don't usually think about. Each connector is grouped by function, and the harness is routed in a way that keeps the higher voltage lines separated from the sensor lines. That helps reduce electrical noise and keeps the readings from the cadence and speed sensors accurate. The harness also includes extra length in certain areas so the bike can tilt or shift slightly during use without pulling on the connectors. Even the shields have a purpose beyond just covering the internals. Put the sweat shield back in place to protect your new controller. Their shape helps guide airflow around the drive system, which keeps the belt and pulley from trapping heat during long rides. The inner ribs on the shields add stiffness so they don't flex or buzz when the bike is under load. All of these small design choices work together to make the bike feel stable, respond quickly to resistance changes, and stay serviceable over time. They're details most riders never see, but they play a big role in how the bike performs behind the scenes. Snap the top cover back in place. Thank you for sticking with us through this video. Please like, share, and subscribe, as it is you guys that keep us going.